So this is section 2.4. And the question says, find the example 1, find the average rate of change for this function, x cubed take away x over this interval. You got to be careful. This picture does not go with that example. And you don't need to do this, but I'll go to the calculator, and it's x cubed take away x. So I'll put it here. And I'll put zoom 4, and there's the graph. What do they want? They want the average change between 1 and 3. Now you can't see where 3 is. Second graph, 3 spits out a 24. So I'd really have to stretch the graph to see that. And I'm going to do something that you shouldn't do, but I'll do it anyway. Ready? Window, the Y max. I'm just going to change this to 25. Now, when I do that, it takes the graph out of perspective. It's like the mirrors on the boardwalk where it, makes you look different. I shouldn't do this, but for the sake of expedience, I will. Where's graph? And you want between 1 and 3. So I look here and it's saying, okay, second graph, I have the points 1, 0, and 3, 24. So I'm going to go over here and show you those points. 1, 0, and 3, 24. Again, you're not doing this. You're just looking up here. So I'm just going to plot those points. And I'm going to draw a line. I'm going to connect them. And I think the line was red, so I'm going to make this a different color. All right. So there we go. And what they said, the average change. The average change is the slope of the black line. The average change between when the input is 0, between the input is 1 and when the input is 3. The average change is the slope of that line. See, the course is about instantaneous change, which would be the slope on the curve, which is changing the whole time. But the average change is just the slope of this black line, which is called a secant line, because it intersects the curve exactly twice. So all you're doing is this, the difference of the y's over the difference of the x's. 24 take away 0 over 3 take away 0. I'm sorry, 3 take away 1. And you would have 12, you'd have 24 over 2, which is 12. That's the slope of that black line. That's the average change for that curve on that specific interval. Okay? Now, example 2 says a different curve. We don't even have the function for the curve. And they're saying this. This is fruit flies. The fruit fly population's in blue. And what do they have? They have a different secant line. After 23 days, you have 150 fruit flies. After 45 days, you have 340 fruit flies. They want the average change from day 23 to day 45. And that's what they did here. And you would just have, ready? The difference of the y's. 340 take away 150 would be 190. The difference of the inputs. 45 take away 23 is 22. And there is your average change. So you have to be careful. There's a distinction. And this is on the assessment. Average change versus instantaneous change. The average change helps you get to the instantaneous change, but you have to be careful what's being asked. So we'll move on to example 3. So example 3 says, we're on page 89. Find the slope of the parabola at 2, 4. So examples 1 and 2 were average change. Example 3 is instantaneous change. So I built this table. See if this makes sense to you. Y equals x squared. So they gave me the input. They gave you 2. 2 squared is 4. So that point's on the graph. Then what am I going to do? I'm going to replace 2 with 2 plus h. I'm going to move h units to the right. You can see this picture in the book. We're calling delta x h. So as you go to the right, in order to do this, you have a small change in x. So the input becomes 2 plus h, the quantity squared. I want the slope of the curve. So I'm going to subtract up. I have this, take away this. 2 plus h, the quantity squared, subtract 2 squared. X's, that's in the denominator, subtract up. What happens? First thing is, you better use a lattice to expand this. You can't distribute an exponent over addition. Combine your like terms. The 4's add to 0. In the denominator, the 2's add to 0. And I'm going to reduce the h in the denominator on both sides of the addition sign, and I'm going to be left with 4 plus h. And then I introduce the concept of, I want the limit as h goes to 0. Now think about this. That's why you're doing a whole chapter on limits. H can't be 0. We're up here, we would have 0 in the denominator. The limit, though, as h goes to 0, the limit of this thing would be 4. So you look in the textbook, what they're doing is saying, here's my h right here, this horizontal change. If I click and drag that to the left, where h is getting smaller and smaller and smaller, this black line, this secant line, is going to go to this red tangent line. So the black secant line, which intersects the curve twice, will then map onto that red tangent line, which intersects the curve once at the point you were told to use, 2. So now I want the equation of the tangent line. Well, the slope of the tangent line is going to be equal to the instantaneous change. It's going to be 4. Now what am I doing? I'm saying my pre-image is y equals 4x, and I'm dragging it 2 to the right up 4 by doing the opposite, and this answer is 100% correct. You don't have to make it y-intercept form. Okay? Now, you're going to go to problem 11. Now think about this, please. You're only doing A and B, which is what we did here. The algebra is going to be a little more involved than we did there, which is good for you. So take your time with the algebra, but this thing right up here is your model. Okay? Okay, so here's what you have for number 11. Here is the function. What is this? It's y equals 1 over x, where it's been moved 1 to the right. So here's the picture. That's what the graph looks like in red. And they want to know, what is the slope of the curve when x equals 2? So if I go 2 to the right, you can certainly tell that the slope is negative. Yes? So now I want to quantify it. So I say, here's the point that I'm given. I'm given x is 2. If I put 2 in the function, I get 1 over 2 take away 1. You get the 0.21. Then you replace 2 with 2 plus h. So I replace this x with 2 plus h. And I'm going to subtract up. my numerator, ready? When I combine my like terms, 2 plus a negative 1 is 1. So this fraction right here would be 1 over 1 plus h. Subtract 1. So instead of writing subtract 1, I wrote 1 in the form of 1 plus h over itself, so you'd have a common denominator. Subtract up. Here's your denominator, and you can see the 2's are going to add to 0. So I took this denominator, h, and wrote it out front to the left as 1 over h. Now I'm looking at the numerator. You have a negative sign in front of this. So you're just going to change, you're going to distribute a negative 1 over this numerator. So it's going to become a negative 1 and a negative h. And these 1's would add to 0, and you'd have negative h over this denominator. I factored out that denominator, put it over here. So now what? Those h's reduce and give you negative 1 over 1 plus h. What you're doing, that's the slope. This is the slope of the curve, depending upon what h is your horizontal, I'm sorry, the slope of the secant, depending upon what your h is, your horizontal change. The limit as h goes to 0 would give you the slope of the tangent. So as h goes to 0, you would get negative 1 over 1. The slope's negative 1. So for my tangent, my parent graph would be y equals negative x, and I'm sliding it 2 to the right, up 1 by doing the opposite, and that's fine, leaving it just like that. Negative 1 times x take away 2 plus 1, and there's the tangent. 2 to the right and up 1. And it's only tipping the graph once, but this tangent has the slope of the curve at the point when the input is 2. Okay? So if you got bogged down in the algebra, the issue is, yeah, I understand it's been a while since you had algebra 2. But you should certainly be able to follow what's in this cell. So if we go back to the book, this is really helpful. See this picture down here, the bottom corner, figure 2.3. If you click and drag on this point and drag it to the left, that's conceptually what you're doing. You're saying h is going to 0. And by clicking and dragging on that a plus h and dragging it to the left, you're bringing the secant black line to map onto that red tangent line. And when you go back here, ready? We're not going to have to do all this algebra continually. Once we get into chapter 3, we will have differentiation rules. But for now, you're doing the foundation of this. The normal line. Ready? We're not going to go into the normal line today, just to tell you this. The normal line meets the tangent line at a right angle. So the product of their slopes has to be negative 1. Well, the slope of the tangent line is negative 1. So the slope of the normal line would be positive 1. And it would meet the tangent line at a right angle and look like that. Now, the only thing, there's no questions about normal lines on your test. But if you got a question in May and you did all the work correctly and you just didn't read the problem carefully and they wanted the normal line instead of the tangent line, that would be kind of a silly mistake to make. Okay? We're going to go to example 6, and it says back to what we did in 2.1. So when you started the chapter, we talked about the force of gravity in feet per second squared. And in this problem, you got to be careful about this. This is feet per second squared. When you see the 16, you know that's negative 1/2 times 32, which is the force and gravity in feet per second squared. So we don't write, now it's positive, why? Because in this question, they're asking you to measure how far something fell, not asking you to measure what the height is, how far it fell. So remember we put this value in H. First thing is on your calculator, go here, type alpha H, and make sure that you got that value 1,000th, because what's going to happen is you have things in your calculator. You may have games, you may have apps, you have programs. Some of them store values in these letters, and if you don't check this, something you unknowingly used overwrote that H, you're going to get an output, and you're just going to, not understand why you got the wrong answer. So we're saying here, ready? This had 0 initial velocity, 0 initial height. Just how far did it fall? And that's what the function is going to tell us. Y3 is the difference quotient. It's going to tell us the speed at that time. So at 1 second, this thing was traveling 32 feet per second. That's the slope right there at that instant at 1 to the right, up 16. You think of the things going up. Okay, so how far did it travel? So that's your model. You're going to problem 27, please. So let me just go back here and say, here's what we have, which is the negative 1/2 times the force of gravity in units per second squared plus the initial velocity plus the initial height. Here's the difference quotient. Second graph. After 1 second, because I made that negative, I'm getting a negative velocity. And what they're looking for in the book, they weren't considering it to be negative, but they were measuring how far it fell. You would get the same absolute value. Okay? So that is it for chapter 2.